Big Chungus. Big Chungus. Big Chungus.
Our journey to sample from the microphone begins, like most coding journeys, by copying and pasting from Stack Overflow. If I copy and paste this code in sequence, starting like here, so it gets the microphone input first, then I copy this next part. So once I hit enter, it'll start recording, and it will stay recording until I copy the code here. And so now it stopped recording. And then if I do play buffer, and it will stay recording until So great, now I have a sample that I can play back through my own function. So that's half of the work done practically. And now I just have to figure out how to integrate this back into my own code. I add a record audio button to the rest of the wave inputs. Since it's initially display none, it's not going to be visible at start. So in the input change function, I have a new function wave change. And wave change is pretty simple. We grab that record button. If we selected sample from the dropdown, we make that button visible. Otherwise, we make it invisible. So I go and select sample, record appears, go and select triangle, it disappears. Now that button, when it's clicked, runs the record audio function, which is adapted from the code I found on Stack Overflow. So this part right here is what asks you if you want to give the browser access to your audio device. And then this then part is everything that happens after you click allow. But note that audio stream, audio node, and recording track are all not declared here because I declared them up at the top up here, which I did so I can refer to them later. Now the audio node is what's doing the recording. Basically, we take what's in the input and we copy it to our own buffer. This line of code right here, I do this so that I can stop the track when I stop the audio recording. It just will get rid of this red recording dot on your tab. Did I even empty the buffer? I need to empty the recording buffer before we use it. That way, if you make a second sample, it won't include the first sample at the beginning of it. And then this part right here changes the HTML so that the button will say stop and it'll change what that button does, which is the record audio stop button. So yeah, this stops it. And then, I don't know, we have like a merge buffer function. This just makes it so that the audio goes from being in an array of an array to just a single array. Eventually we get this normal buffer. If you were to put the normal buffer into the play buffer function, it would play back the audio. We have a sample data array, which is just like octave or pulse amount, phase, so on. We save the normal buffer to that, and we get rid of record and replace it with the sample playback. And the sample playback is pretty simple. Just take our sample data, save it to the sound array, and then run play buffer, which plays the sound that's in the sound array. And so you can see this in action. Switch to sample, hit record, hit allow, start talking, and then when you hit play, start talking, it played back the audio. If I add another waveform, right, and do it again, I should be able to record a different sample, and then they should be two unique ones. So let's see if that works. Start talking. Yeah, okay, they're distinct. Now, the only issue is the script processor node is deprecated and has been deprecated for almost a decade at this point. And while you could replace it with the audio workload node, no one has to know. So now we have our sample and our data. How do we play it at a range of different frequencies? Well, this is the part of the code where we do our different types of waveforms. If I just do something very simple like this, if I is less than sampdata.length, then play the sample. Otherwise, do nothing. This should just play the sample back at the rate at which it was recorded at. Why don't I hear it? Oh, you know what's happening? Is that right here, I'm setting I'm modding it by the period. And so since the period is something like 122, we're only playing the first 122 samples. So I have to use old I here. Yeah, we could play the sample in a sequence, but it doesn't have any pitch information associated with it. The way I'm going to get the pitch information is I'm going to take the frequency. I guess I'll just assume that whatever sample you're doing is recorded in F, which that's the frequency, right? I can press... Right, those are all the different frequencies that we have. I specifically want F just because it's in the middle of the keyboard. Copy this 349 number. I guess I'll call that my reference frequency. Now, theoretically too, you could do some analysis on the sample to figure out its actual fundamental frequency, doing Fourier transforms, and then taking the maximum on the frequency chart. That's complicated. Don't feel like doing that right now. And now up here we know that the S freak is the frequency of the note that we're hitting. I can get the play rate by doing something like S freak divided by reference freak. We multiply that play rate by our I, or iterator, through the sample frequency. and then we're gonna probably need to parse int it because otherwise it won't be an actual index. We should then have different playbacks maybe? I don't know, we'll see. That's the actual sample I got. Now we have different rates that it's playing at, and we have pitch information. I can make a melody out of it. Okay, the sample's really short is the issue, so it's just like the very beginning of it. But I could change the seconds per measure to make it so I can hear more of that. And I could even go and drop the octave and see what that sounds like. Did that even do anything? You know, I don't even think it's taking the octave information into account. It does take the amplitude into account. Oh, that's cool. It takes the pulse information into account. So you can start like bit crushing your own samples of your own voice. And then you can add more samples and make it more cacophonous. Yeah, how's this gonna sound? I have a violin over here. Does this even work? Let me try recording from this. Yeah, okay. You know what? That's good enough. I shouldn't be using sfreak. I should be using freakw. And if I do that, it'll take octave information into account. What does that sound like? Now if I mess with the octave... so yeah, you can use decimal numbers in here if you want to tune it. Man, I really gotta make it so you can have, like, more than, like, these really short notes. You know what I'm getting, I really feel like I need to do is I really need start and stop points. I'm just gonna do sample start because most of these samples you don't reach at the end of anyway. So I just kind of like do a bunch of data churning to get this into all the different places it needs to be. I need to give it an initial value. That initial value is 0. When deleting the wave, we have to make sure that we get rid of it. Add a new case for it in the input changed, so like that. Okay, I think it's in all the right places. So now I need to actually use that variable. I'll make a start offset, which is just the sample rate multiplied by that samp start variable instrument W. So that's good. Oh, I also have to show and hide it within the elements. Okay, so we grab the samp start element, basically just duplicate what we had before, and then that box will show and hide. No, because sample start is still here. Ugh, right, because sample start's not part of it is the issue. I need to create a span around it, call it the samp start container, I guess. Move the display none from here to the span. If I hit sample, it's got a sample start variable. And if I record, I can record, right, but if I change the sample start to like 0.4, record, it starts at a different place. But you know what, I want to make it so that when you do the playback as well, it will start at the place where you want it to start. That does require me to make a new for loop in here now. But it's just like before, we make a start offset, which is the sample rate, multiplied by the samp start data. I can just parse int that in this case. We set our play buffer to nothing to clear it. Then we iterate from the 0th index up to the length subtracted by the starting offset, and then we just add the start offset to our index. Let me just make sure that works. Does it work? And now if I do 0.5, work. Okay, cool, it does work. Work. Does it work? Does it work? This is in a live demonstration. This is in a live Okay, yeah, one other thing I wanted to probably do is integrate this into the save and load feature. So yeah, that massively increases the amount of data that we're saving in the cookie. Why didn't it work? We can't save more than 4 kilobytes in a cookie, so we can't actually save the sample data in the way that I'm saving it. So unfortunately, because I don't feel like doing a fix to this right now, you can't actually save your samples. Theoretically, to make this better, there are definitely some things that you could do. Having the ability to upload a sample as a file instead of recording it from your microphone. And second, having it so that you can do an export and import in which you save to and from the computer. That would let you actually save the samples. But, you know, I mean, for what it is, it works, you know, at a very primitive state right now. And it does work, and it is fun.
Big chungus, big chunk, big chungus, big chungus, big chungus, big chungus.